today we're going to talk about section 2.4, finding maxes and mins of polynomial functions. Your homework is page 71, 1 to 5, 9 and 11. You can go ahead and cross out page 72, 1 and 3. You do not have to do that. Our first example is to graph the function f of x is x squared plus 4x plus 3. If you remember when we talked about how to graph, we talked about finding roots. So the first thing to do to find roots is to factor it. So you'd say 0 is equal to x squared plus 4x plus 3. And then that factors to x plus 3, x plus 1. So your roots will be x equals -3 and -1. Now if you think back to your Algebra 2 days, to find the max or min of a function, you would need to use the equation x is equal to -b over 2a. So in this equation, the x value will be -4 over 2 times 1. So at -2, we are going to have a max or min. Because the a is a positive, it will open up. So a is greater than 0, so we have something that opens up. So this is your min. So therefore, it happens at -2. We just plug in f of -2 into the original equation, and you'll get -1. So your graph, you go to -2, -1. You're at -3 and -1 for your roots, and it goes up. And it also crosses over here at 3. For your y-intercept. And that would be how you'd graph this equation. Example 1 tells us two numbers have a difference of 6 and you want to find their minimum possible product. So let's put this over here and write out some equations. So if two numbers have a difference of 6, you can say that x minus y is equal to 6. So solving that, you always want to solve it in terms of one variable. So that would mean that x is equal to y plus 6. And if you're trying to find their minimum possible product, the product is just going to be x times y. So we're going to take what x equals and we're going to substitute it in right there. So now we have the product is y plus 6 times y. So that's y squared plus 6y. Now don't worry that it's a y or an x. It could be any letter you wanted it to be. And the rules of the quadratic formula still hold true, except it won't be x is -b over 2a. It's going to be y equals -b over 2a. So it's -b over 2a. So your b is 6, so it's -6 over 2 times 1. So when you take -6 and divide by 2, you will get y equals -3. So once I know that y is -3, I'm going to plug it back into the original equation and say x is -3 plus 6, so x is going to be 3, which means your minimum product is 3 times -3, or the minimum product is -9. So example 2 tells us the sum of two numbers is 20. You want to find their maximum possible product. You should pause the video at this point and see if you can come up with the two equations. So pause now and try to come up with your equations. Okay, so hopefully you came up with two equations. The sum of two numbers is 20. I'll say x plus y is 20. And their maximum possible product will be p is x times y. So as we did in example 1, I will solve the first equation for one of the variables. This time I'll solve it for y. Y is 20 minus x. And then I will plug this back up into here. So the product is x times 20 minus x. So your product is 20x minus x squared. Now some of you might find it more helpful to write it as negative x squared plus 20x, and that will help you get your negative b over 2a. So let's just go through. Now we're going to find x is negative b over 2a to find our max or min point, and we're finding the max possible product. So the value that x will be to give us our max possible product will be negative, the b is 20, and 2 times negative 1, because our a is negative 1. So negative over negative will just be a positive, and you'll get x to be 10. That would mean that y is 20 minus 10, so y is also 10. And your product is just going to be 10 times 10, so your answer will be the product is 100. Example 3 says a rectangular garden is made with 100 meters of fencing on 3 sides. So it's important to note it's just 3 sides. The fourth side is a stone wall. You want to find the greatest possible area of the garden. First thing you want to do is draw a picture. See if you can draw the picture and then hit play again when you're done. Okay, so hopefully you drew that you have a wall, and that's in blue, and then my red is my actual length of the fencing. So for practical purposes, I'm just going to call this x, and I'll call this y. So my equation for the perimeter of this is that 2x plus y will equal, you have 100 meters of fencing, so that equals 100. So I can solve that for y and say y is 100 minus 2x. But if you remember, we're finding the greatest possible area. So I will come over here and say area is still going to be just x times y. So I'm going to plug it in. It's x times, I'll take this and put it here, so that'll be 100 minus 2x. So my area is going to be 100x minus 2x squared. And remember, you're trying to find the max possible area, so the value of x will be negative b over 2a. So I'll get negative 100 over 2 times negative 2. And when you do that, you're going to get x to be 25 meters. So plugging it back in, you have 2 times 25 plus y has to be 100. So y is going to be, you have 50 plus y equals 100. So y is going to be 50 meters. So your area is 25 times 50. So your max area will be 1,250 meters squared. As I said before, we will do examples 4 and 5 together in class. We will need graphing calculators for those. You will need your calculator for this one just to help you out a little bit with the calculations. But let's read it and see what it is. You have an orange grower has 400 crates of fruit ready for market. And will have 20 more each day the grower waits. The present price is $60 per crate and will drop an estimated $2 per day for each day waited. In how many days should the grower ship the crop to maximize his income? So you're trying to find income. And income is going to be the number of crates times the price per crate. So our number of crates, if you go back, you're going to see they had 400 crates and you get 20 more each day. So you start off with 400 and you're increasing it by 20 per day. And that will take care of our number of crates. The price is $60 per crate, but will drop $2 per day. So you're going to say that's 60 minus 2D. If we go through, and we're going to multiply that out, you will get 24,000 minus 800D plus 1200D minus 40D squared. So the final one is that income is negative 40D squared plus 400D plus 2,400, or 24,000. So you're really you're trying to maximize the D, which will maximize the income. So your D is going to be negative B, so negative 400 over 2 times A. And that should give you 5 days. If they asked you for the max income, you would just plug this 5 back into this equation here, and you'll find the maximum income. But it really only asked you for how many days.